Chapter 9, we take a short foray into the geometric world and we explore points, lines, planes, and angles. So while this may make some of you break out in sweat, hopefully we're going to take it step by step. We're going to break down some of these concepts and definitions and put them to use. So the most basic geometric thing we will study throughout our entire education is just a point. A point is like a coordinate on your GPS, like dropping a pin. This is the easiest way to think about it as dropping a pin or a location on a map, because a point corresponds to an address to give the specific location of it. So while a point has a location, it doesn't really have any unit of measurement. So we say it's dimensionless because I can't say that the point is 2 meters long. Like when you drop a pin on the map, it's just a pin on the map. It doesn't have any meaning in measurement terms. A line is a set of connected points with an infinite length but no width. Here is where the misconception happens. A line extends forever on either side of the two connected points, or any more than two connected points. It goes forever. So it's not as simple as drawing a line on a sheet of paper or tracing a line. It is an overall concept that the line extends forever on both sides. It's also an assumption that it's straight, and in actuality, a line exists in this one-dimensional feel, and it also doesn't really have a measurement because it's an infinite length, and lines don't really have a thickness. So when we're talking about them, again, they're difficult to measure. A plane is a sheet of paper. So if you hold your sheet of notebook paper in the palm of your hand, it's a plane. It's just a flat surface. So ignore the idea of dimensions and all of that for right now. But a flat surface is a plane. The top of your desk is a plane. Now that doesn't include the thickness of the desk, but just the very top of the desk. That is a plane. So it's helpful to think about a plane as a piece of paper. But the main difference that's conceptually hard for students to understand is that a plane, like a line, goes on forever. A sheet of paper has a definite start and stop. The top of my desk has a definite start and stop. But in the true sense of a plane, it would extend out lengthwise and widthwise forever. And that's where it can be a little bit harder as they approach those high school years, because we really haven't cemented that understanding of it in the lower levels. A line segment is what we're more familiar with. A line segment is finite. It has a start and it has a stop, and it has endpoints at either end. A line segment includes an infinite number of points because there's 1,000,001 different ways to draw points on that segment. Any point on a line that separates it into two halves we call half lines. A half line begins at point A and continues through point B, which means that A is the endpoint of the half line and B is about the halfway point. When an endpoint is used with another, so I have an endpoint meaning a start or a stop, and then the rest of the line just keeps going forever. So only one end of my line has a definite start or stop. That is called a ray. So what do these actually look like? A line extends forever, and the symbol is used with any 2 points on the line, it doesn't matter which two you choose, and an actual line above them. A line segment is shown with the endpoints, and it's also named using the endpoints. The half line is starting at A, and it goes all the way to B, and it goes on forever. So the difference in a half line and a ray is that a half line has an open circle and a ray has a closed circle. That's the difference. We're not really going to address that difference a whole lot in this course. And a ray has to be named with the endpoint as the first letter and then any point on the ray as the second letter in the symbol. An angle is therefore formed by two rays with a common endpoint. So that's a very different definition of an angle than we teach our students sometimes. But basically an angle is made by putting two rays together at one endpoint. And each ray is called the side of the angle, and the endpoint of each ray is called the vertex. So the symbol for an angle is the little angle with a I guess a crescent through it would be the appropriate term. And there are a number of ways to name angles. I can use any combination of the 3 points where B being the vertex is in the middle. I could also call it just angle B because B is in the middle, or I could call it angle 1 by determining the inside of it as angle 1. Typically, we'll only use a single letter to denote an angle if there's no question about the angle that's being represented. So if you look at the example here, if I call this angle B, you don't know if you're talking about this angle up here or this angle down here. So we would avoid saying angle B in this case because it's a little ambiguous. So as an example, if I want to name the angle that's shown here in 4 different ways, then I'm going to take it and I'm going to make sure that that vertex S stays in the middle of my letters. I could also call it angle S, and I could also call it angle 3 because the inside of that angle is denoted with a 3. And then in part B, write 3 different angles that have point B as their vertex. So ABC, CBD, or ABD. So there are 3 distinct angles that are being shown in that example. One way to measure an angle is in degrees, and degrees tends to be a bit more of the English system. So degrees is kind of like inches. It's a common measurement. We're able to visualize it a lot easier than the other measurement, which is radians. So we use protractors, and those have slowly kind of gone out of practice in the lower grades, but there are some really great virtual ones that we can actually use. And to do a protractor, we're going to center that vertex at the center of the protractor. We are going to align the bottom of the protractor with the ray, and then we are going to see what number the angle crosses. Angles have some specific classifications. They can be acute, they can be right, or they can be obtuse. An acute angle is an angle between 0 and 90. A right angle is exactly 90 degrees, and an obtuse angle would be an angle that's between 90 and 180. A straight line is exactly 180 degrees, and it forms a straight line. Pairs of angles can have different terminologies that describe them. 2 adjacent angles are next to each other or adjacent when they share a vertex. So if you look at angle 1 and angle 2, they share the vertex point B. And for this reason, we say these are 2 adjacent angles. 2 angles can also be described as adjacent and complementary if they add up to be 90 degrees. So for instance, if I have an angle that's 60 and an angle that's 30, so let's say angle 1 is 60, angle 2 is 30, these are complementary angles because they add to be 90 and they share a vertex. If they're supplementary, it means that they share a vertex and they add to be 180 degrees. So let's say that angle 2 is 100, angle 1 is 80, they add together to be 180, so they are supplemental. So how do we actually use this in problems? So when we're looking at problems, we will be solving for different things given the vocabulary being used. So in this example, we say that these 2 angles are complementary. And I know that angle GEF is 28 degrees. Well, if I know they're complementary, then I know that 28 plus the measure of DEG is 90. So therefore, if I take 90 minus 28, I get the complement as 62 degrees. The same thing happens here in the problem where they give me 2 adjacent angles, they share a vertex, and it says, hey, these 2 things are supplementary, which means that 135 plus angle PQS equals 180. And so to solve that, I'm going to do 180 minus 135, which tells me the supplementary angle has a measure of 45 degrees. Another example is a slightly algebraic variation on this. So a lot of what we do in our geometry classes is we try to start integrating the ideas of algebra into the concepts of geometry. So if I have two adjacent angles that are supplementary and one angle is 3 times as large as the other, find the measure of each. Well, I know I have one angle that's x, one angle that's 3x, and when I combine them, they're supplementary or equal to 180, which is how I generate this equation. Now to solve this equation, if I have x plus 3x, I now have 4x's, and then I have to divide both sides by 4, and I get that x is 45. So my smaller angle is 45, my largest angle is 3 times the larger than the other, so I would do 3 times 45, or 135. Another way of describing angles are vertical angles. Vertical angles, all 4 angles share a vertex, not 2, 4. And in a vertical angle, there is a unique relationship that happens. If I'm looking at vertical angles 1 and 3, they are going to be the same measure. If I'm looking at 2 and 4, those are going to have the exact same measure. So if I use the image on the previous slide, and angle 2, 3, and 4 are what I'm looking for, and I have the angle 1 is 40. So this angle is 40 degrees right here. Then that means that angle 3, by definition, is also 40 degrees. Now the question becomes, how do I find angle 2? Well, angle 3 and 2 are going to be supplementary because they're going to form a straight line if I add them together. So if angle 3 is 40 degrees and I want to find the measure of angle 2, I'm going to do 180 minus 40 is 140 degrees. So that tells me that angle 2 is 40 degrees, and because angle 2 and 4 have the same measure, angle 4 is 140 degrees. Now, parallel lines have some interesting implications related to this idea. Parallel lines are 2 lines that never intersect. If a line is drawn across 2 parallel lines, we call it a transversal. That looks like this. I have the parallel lines L1 and L2, and then L3 crosses them and it forms the transversal. Now what you should notice is when it forms that transversal, I have vertical angles being here. So yes, there is a vertical angle relationship. However, geometry tends to talk about interior angles versus exterior angles. That's the proper terminology. Interior angles are angles between the parallel lines. So 3, 4, 5, and 6 are between the parallel lines. Exterior angles are outside of the parallel lines. So that would be 1, 2, 7, and 8. When 2 parallel lines are crossed with a transversal, we have some interesting relationships. I have alternate interior angles, so angles that are inside the parallel lines but on opposite sides, like 3 and 6, are equal. The same applies to 4 and 5. They're inside the parallel lines and they're on opposite sides. They're also congruent. If I look at exterior angles, they have the same pattern. Alternate exterior angles would be angles that are outside of the parallel line but on opposite sides, like 1 and 8, 2 and 7. So in this case, 1 and 8 are equal and 2 and 7 are also equal. Last, we have what we call corresponding angles, and traditionally that is the angle that is the toughest to identify for students. Now, corresponding angles are located in the same place on different pairs of angles. So, if I look at angle 1, it's in the top left of this little circle of angles. If I look at angle 5, that angle is in the top left. So those are corresponding angles, which means they're equal. If I look at angle 8, it's in the bottom right, and angle 4 is in the bottom right. So those are corresponding angles which have the same value. Now we're going to look at an example. If I know that angle 2 is 50 degrees, I want to find the measure of every other angle. Well, if angle 2 is 50 degrees, I know that angle 3 is also 50 degrees because they are vertical angles. I also know that 2 and 7 are alternate exterior angles, which means angle 7 is also 50 degrees, and then angle 6 is also 50 degrees by vertical angles. Now I'm kind of stuck because I need 5, 8, 1, and 4. So it's important to remember that 1 and 2 are going to be supplementary angles because they're on a straight line. If angle 2 is 50 degrees, I'm going to do 180 minus 50 is 130. So therefore angle 1 is 130 degrees. By vertical angles, that means that angle 4 is also going to be the same measure. And then by alternate interior and exterior angles, I can then prove that my other angles that are missing are also going to be congruent. And this is the solution that I just walked you through with a lot of extra text worked out.